Imagine you're working on a web server project, setting up a user interface with essential buttons like Start, Stop, and Reset. You've managed to get everything configured, but there's a problem: the buttons are unresponsive. Each press requires multiple attempts before the state changes from 0 to 1 or vice versa. This sluggishness not only frustrates users but also indicates underlying performance issues. The root cause could be direct access to peripherals, inefficient coding practices, or suboptimal configuration settings. Understanding and resolving this problem is crucial for delivering a seamless user experience. And here's why that matters: a responsive interface is the cornerstone of user satisfaction and system reliability. Let's dive into the specifics to uncover what's causing this delay and how to fix it. The sluggish response of your web server buttons is directly tied to how inputs are mapped. When you map buttons directly to PLC inputs, every button press triggers a direct read and write operation to the PLC memory. This creates a bottleneck, especially under high load or with multiple instances. To illustrate, imagine your PLC memory is a busy highway. Each button press is a car trying to enter. Direct mapping is like allowing every car to enter the highway without any traffic control. The result? Traffic jams and delays. Instead, map your buttons to a data block, DB. This acts as a traffic controller, consolidating multiple button presses into fewer, more efficient operations. You'll notice a significant improvement in response time. And here's why that matters: efficient input mapping not only enhances user experience but also reduces the load on your PLC, allowing it to handle more complex tasks without performance degradation. Now, let's delve into setting up a database as an intermediary to enhance web server response times. The key here is to decouple the direct interaction between the user interface and the hardware inputs. By introducing a database layer, you create a buffer that smooths out the latency issues. Imagine your database as a high-speed relay station. When a user presses a button, the request is first sent to the database, which then communicates with the hardware. This not only speeds up the response but also allows for more complex operations and state management. To implement this, you'll need to configure your web server to interact with the database using SQL queries or a similar method. Set up a table for storing the button states and use triggers or stored procedures to handle state changes efficiently. This approach not only resolves the sluggishness but also opens up possibilities for advanced features like logging and analytics. Now, let's delve into enhancing your user interface without compromising performance. You've already noticed that directly linking buttons to inputs can cause sluggish responses. Instead, map your buttons to a data block. This reduces the load on your system and speeds up state changes. Consider integrating a modern framework like Bootstrap to give your UI a contemporary look. It's lightweight and won't bog down your system. If you're thinking about animations, SVG is your friend. It's scalable and efficient. Remember, the key is to keep your UI responsive by offloading heavy tasks to the back end. This way, your front end remains sleek and fast. Now that we've tackled the core mechanisms, let's delve into advanced techniques for optimizing performance. One critical aspect is the reduction of latency in web server interactions. Imagine your web server as a high-speed relay race. Each handover must be swift to maintain momentum. To achieve this, consider implementing asynchronous programming techniques. This means your PLC should handle multiple requests simultaneously rather than sequentially. Another key factor is the efficient use of memory. Think of your PLC memory as a well-organized library. By categorizing and indexing your data, you significantly reduce search times. For instance, using structured data types like arrays or linked lists can streamline data access. Additionally, fine-tune your network settings. A baud rate of 19,200 is often optimal for legacy devices, ensuring a balance between speed and reliability. Remember, every millisecond counts in a high-performance environment. And here's a pro tip: regularly update your drivers and firmware. Outdated software is like a rusty cog in a machine, it slows everything down. By keeping your system up to date, you ensure that all components are working at their peak efficiency. Let's dive into common pitfalls that cause slow responses in your web server setup. One frequent issue is direct access to hardware inputs, which can significantly slow down response times. Instead, use a database block to buffer your inputs. This method reduces latency and improves overall performance. Another pitfall is the overuse of complex libraries like jQuery or Bootstrap. While these can enhance your user interface, they can also introduce unnecessary overhead. Opt for lightweight alternatives or minimize their use to keep your web server nimble. Lastly, avoid excessive polling of variables. Implement efficient data handling techniques such as change detection or event-driven programming to minimize unnecessary network traffic. Remember, the goal is to maintain a responsive and efficient web server. And here's a pro tip: regularly review and optimize your code for any redundant operations that could be slowing things down.